Let's continue with our questions.
We need to calculate this question by ourselves. Let's do it. Limit x goes to infinity 5 over infinity. If your numerator is low, something really low, and denominator is something very big, you get closer to 0, 0 plus, like very little number, and it makes 0. Check this question. Limit x goes to infinity 15 over infinity square makes infinity, which is 0. It gets closer to 0 from positive way. Let's check this question. Again, we calculated limit x goes to minus infinity over 2 over negative infinity. This time you get closer to the 0 from the negative side, so we write 0 over minus, but it actually makes 0, so there is no difference. If we need to generalize, I'm gonna write a new rule to summarize it. So let's move on to the other questions. In these questions, we are gonna put infinity instead of x, but if you replace this, you get infinity over infinity. But as I said before, this case is indeterminate. In such cases, we are gonna try to rewrite the equation. So we cannot factor this out, so we are gonna try something new. In these types of questions, when you can't factorize, what you are gonna do is you are gonna divide all of the variables with the highest exponent. In this question, highest exponent is x, so we are gonna divide everything with x. Let's do it. These and these cancel each other, and we can write the limit as, if you put infinity instead of x, you get 0 here and you get 0 here, so these have no role in this equation. So basically this is 7 over 2. Let's look at this question. Again, in this question you are going to divide all of the exponents with the highest exponents. In this question, highest exponent is x squared, so we are going to divide everything with x squared. So these cancel each other. You have x here, you have x here, so I'm gonna rewrite the equation. If you replace minus infinity with x, you get these and these 0, these 0, so they have no role for the equation, so you get 8 over 16, so 1 over 2 is your answer. So we have a rule over here, so let me write the rule. As you see here and here, the result is the division of the coefficients of the highest exponent. So we just made a rule about it, and it says if the highest exponent of the numerator is equal to the highest exponent of the x in the denominator, then limit will be the division of the coefficients. So we don't have to do all these calculations. Instead, we can just get the highest exponent here and here. We can divide the coefficients as 7 over 2, as 8 over 16, 1 over 2. So it's that easy. We have another example here. As you can see, highest exponent of the numerator is not equal to the highest exponent of the numerator. So we are gonna do the same thing that we did previously. We are gonna divide by the highest x. Limit x goes to infinity. These will cancel each other. We have x here. So these will be all 0, and this will be 20, so 0 over 20 will be 0. Let's get into this question. We will do the same thing. We will divide by the highest exponent that we did previously. We're going to divide with x over 8. So this will be 0, this will be 0 too, so 0 over 15 equals to 0. We can make a generalization here. I wrote the rule in case you need. This is the shortcut of these calculations. If the highest exponent is in denominator, then the result is 0. So we have another example here. As you can see, this time the highest exponent is in the numerator. We are gonna do the same thing. We are gonna divide it with the highest exponent. These will cancel each other, and we're gonna have and these all will be 0, so 5 over 0, and this will be a little bit bigger than 0 because since we do the limit, so it will approximately be infinity. This is vice versa. So if you have the highest exponent in the numerator, then your result will be infinity. And I will write the rule in case you need it in a physical way. So guys, I've wrote the rule and I just wanted to make some a clarification. We can use this rule in case x goes to infinity. If x goes to 0, we cannot apply to these two rules, so be careful about this. We are done with this video. Hope to see you in the next video. See you.